Okay. Hello, scientists. We're introducing an idea to extend our learning at home with an optional activity. I happen to have a big whiteboard. You could do this on paper, but the big things are that I spelled out my purpose. Here at the top it says the purpose. Does surface area affect the rate of evaporation? This is an experiment that we did in class, but I wanted to extend it at home. You could do something different, you could do something similar, it's all up to you. 5 big parts that you need to have: the purpose, your materials, your procedure, your step-by-step procedure, a small picture, my hypothesis, and then eventually my conclusion. My purpose again is, does the surface area affect the rate of evaporation? I've spelled out all the materials I'm using. I'm using a plate, a bowl, a cup, a small mug, water, a half cup measuring cup, iPad, whiteboard, and markers. My procedure, step 1 is to put exactly a half cup of water in the cup, bowl, and on the plate. I'm going to place all 4 of these containers in the same place. I'm going to leave them here on the kitchen table. And then I'm going to mark the area, I'm going to mark the cups and bowl with a mark with the level of the water. After time, I'm going to come back and observe these and see which one evaporates the fastest. My hypothesis says, based on my prior knowledge, classroom experiments, and the videos, I think that the plate will evaporate at the fastest rate. Surface area will have an effect. You can do your purpose on a piece of paper or a piece of construction paper, whatever you decide. Here, I have a bucket of water. It's at room temperature. It's been sitting out in the room for a while. I'm going to take my measuring cup and put a half cup of water on the plate, the bowl, the cup, and then in the small mug. Tomorrow, I'm going to see how much water evaporated from each and try to determine which one evaporated the fastest. Very carefully, I'm pouring the half cup of water on a plate, making sure none spills so it's a fair experiment. Taking exactly a half cup of water, putting it in my bowl, which changes the surface area because the water is touching less air. A half cup of water in this glass. And very carefully for my mug, take a half cup of water, making sure to be fair so I have exactly a half cup, and pouring it into the mug. Now, as you can see, as we know, the surface area is the amount of water touching the air. The mug has the smallest surface area, the cup has a little bit more surface area, the bowl has a little bit more, and then the plate has the most. This is a fair experiment because all the cups are in the same location. One's not outside or inside. They're all here on the table. The air temperature is going to stay the same, and I've used exactly the same amount of water for each cup. Tomorrow morning and then tomorrow evening, I'm going to check in and see how much water has evaporated. To keep track of that, since I don't have a syringe or exactly the tool I'd like to have, I'm going to take the marker and mark the level of the water in each cup. It's kind of hard to see, but I put a black mark right there. Put a black mark at that level. I'm actually going to make a mark on the inside of the bowl since it's not clear. If I had a clear bowl, that's what I would use. On the plate, it's very hard to see, but I'm going to put a mark right where the edge of the water is. This way, if the water evaporates, if there's less water here, I'm going to know where it would have been, or where it was, rather, when I started my experiment. This is one way to design an experiment. You could also test the temperature of the water, you could test the location of the water, you could put, there's lots of different ideas, lots of different ways that you could test the different properties that affect the rate of evaporation.